Hey there! This is a how-to guide for creating computer-generated three-dimensional models of three-dimensional objects from two-dimensional photographs. This is really the basis of ground-based photogrammetry, and ground-based photogrammetry works on the theory that from two overlapping photos, it's possible to calculate the unique three-dimensional location of a set of given points shared in both photos relative to the camera. That is a direct quote from this paper here from the Journal of Structural Geology that gives you a pretty good overview of ground-based and UAV-based photogrammetry. So I suggest you Google Scholar this and read up on what some of the experts in the field are saying. Before we start, we need a couple of programs. 3 to be exact. The first one, is called VisualSFM, Visual Structure for Motion, and it's created and maintained by Chang Wu. And this program takes in a set of photographs that you will be taking and computes those unique 3D locations and the set of given points shared within the photos that you upload. When you download VisualSFM from the website, it's a bit buggy. And so to expedite the application, I have created sort of a master folder here, VisualSFM, that I will somehow get to you either before you see this tutorial or shortly thereafter. It contains within it several executable and application files that for some reason do not come standard with the package that you download from the website. The second program you're going to need is Meshlab. And this is sort of the workhorse, if you will. I guess all three are pretty workhorsey, but this one in particular is where we do the post-processing. So you're going to create a point cloud in VisualSFM, and you're going to import it into Meshlab and start the work. There are a couple of different programs that you can use in lieu of Meshlab. Cloud Compute is one, Mesh Mixer is another. I do not know either of those well enough to give you any sort of advice on how to use them, so we're going to be using Meshlab. But if you feel like you would rather use a different program, then by all means go for it and maybe share your workflow with others. It's a really collaborative process. I learned a lot from YouTube videos and just goofing around. The third program you're going to need is called Blender. And this is a really interesting and powerful visualization software that I can't really explain well without showing you how it works. But just for now, just believe me when I say we're going to need this. And so go ahead and download Blender. This version, 2.77a, is fine for what we're going to be doing, so go ahead and do that. Okay, so we are going to get started. I should mention, just before we get started, this is my first attempt at giving any sort of tutorial with screen capture, so I apologize in advance if things look a little jerky. I'm going to do my best to make everything flow and seem like I've been doing this for years and years. So you're going to go out and choose an object that you think you can capture with somewhere between 100 and 200 photographs. You can of course use more, but you're going to need a lot of processing power to do this. These programs, VisualSFM, Meshlab, and Blender, are capable of processing larger sets of data, but the system really slows down. And I've tried to streamline this tutorial with tips and tricks so that you can do this part of your coursework directly on your home PC, so you're not sitting in the lab for 12 hours. Hopefully it doesn't take 12 hours, but if you try to process a lot of photographs, it's going to take somewhere close to that. Okay, so I went out on campus. As you can see, it is July. So it's nice and quiet, and I was able to photograph this rock that looks as though it's been painted over 100 times. It's a great color. Purple is easily seen in clouds. It has cats on it, which is a bonus because I'm an animal person. I love cats. I've got a couple myself. And I know Chris particularly loves the felines, so I figured, hey, this is great. Purple cat rock. I'm going to just close out there. When you go out, you have all your photographs, you come back to your computer, you upload them, you need to compile your photographs into a standalone folder. So you can see here, I have it in a standalone folder. When you run these programs, the folder will populate with output files that all need to be contained. So if you ever need to start your project over, you need to do this step again. You need to move only the photographs into a new folder. VisualSFM, our first step, won't run if the folder has other files in it. I don't know how to get around this quirk, and so I've decided to not waste time on trying to figure it out. Just always move the photos into a new folder. All right, so let's start by first opening VisualSFM. You can do so from the folder here. If you open up, there we go. You can run it right from this application, or you can pin it to your taskbar like I have, because I use it quite often. These are the dialog boxes that pop up when you open the program. Okay, so now we are going to upload all of the photos into VisualSFM. You can do that by clicking this button right here, or going to the file and clicking Open Multi-Images. I'm going to find where I put them on the desktop there. I'm going to click the first photograph, hit Control A, selects all the photos. We're going to open them up. You see that second dialog box sort of disappears. You can bring it back by clicking this button right here. There we go, it's popped up. And if we scroll down right to the end, we see this thing loading image pixel data. This takes a couple of minutes to do, and so we will come back once that's completed. Loading the pixel data took 81 seconds, so while these processes are happening, I'm going to stop the recording because no one needs to wait 81 seconds in silence. So we just zoom out here and we see that all the photos are in VisualSFM. Now we're going to hit this button, Compute Missing Matches. This process detects key points in the images and matches these up with matching features in other images. So let's go ahead and click that button. And we have a nice warning here, which I always ignore. What the computer is now doing is running SIFT files. There's a lot about SIFT on the internet, so I encourage you to go and learn a bit more about it. And we're going to once again leave and come back because the SIFT takes a little bit of time as well. All right, we are back. Computing missing pairwise matching took just a little bit over an hour. I don't think I've mentioned it before, but maybe it's been apparent that the processing power needed by the computer is pretty big. I would suggest that when you are doing this kind of processing, you make sure that your computer doesn't have anything else running in the background. I would suggest closing down browsers, closing down applications, and just letting the computer run what it needs to do. Okay, so we have computed the pairwise matching. Now we are going to click the next button, Compute 3D reconstruction. So I will click that, and here it goes. This is the sorcery that is structure for motion, because it takes the match points and calculates the positioning of each photograph. And you can see this as it slowly materializes on your screen. Alright, so the computing of the 3D reconstruction has run. It does not take as much time as the other processes in this workflow. It took about 153 seconds, so just over 2 minutes. And what you can see here is the camera positioning with the points associated with it. It's actually pretty cool. So what I'm doing now is just hovering my cursor over the space and right-clicking, and that allows me to pan. Okay, so I ran into a few issues, which just goes to show that no matter how well you know the program or how often you use it, you still find little quirks that you weren't expecting, as you can see here. So that's what all this was. Anyway, what I did following the computation of the 3D reconstruction is I hit this button here, compute bundle adjustment. Run bundle adjustment. And this only takes the computer a few seconds, so you see that there. So again, once your 3D reconstruction is done, hit bundle adjustment. Now that all that has run, you're going to click the adjacent button, run dense reconstruction. This creates the dense cloud reconstruction of the model, and this is what requires the bulk of the time in this particular workflow. These reconstructions can last hours, depending on the speed of your machine. I suggest running it overnight. This particular reconstruction will take my personal computer somewhere between 2 and 3 hours to complete, but again, it depends on the power of your computer, how many photos you use, and how many points were generated. I advise not using your computer during this time, just letting it run, which is why I also suggest doing it overnight. So we're just going to go ahead and click Run Dense Reconstruction, and a dialog box pops up. This is where you're going to save. And we are just going to name it something, PCR tutorial dense. And you are going to save it, and you're just going to let it run. So we'll resume in the morning. Okay, welcome back. The dense reconstruction has finished. You can see here that it took just under 2.5 hours to run, so not too bad, but definitely glad that I ran that overnight. And what you're left with is this point cloud. It's not really, you can't really tell what's going on. Let me just open up this window and keep the log window up to the side here. The beauty of this program is that you can toggle between the dense reconstruction and the point cloud. So what you're going to do is hit the tab button, and here it is. This is your dense mesh. So it's pretty cool. I'm going to go slow here so that I can get the whole capture. And I'm going to zoom in. Here we go. And you can actually make out these cats. So we're just running around. You can see the writing on the back. Not sure what that means, but that's okay. Alrighty, so we're going to save this. So we go into File, SFM, Save and View Match, Dense, done. You're going to hit Save. Then you're going to save it once again, but this time you're going to save a PLY file, which is a cloud file. dense.ply. Save. Alright, you can see the log window has tracked all of that, and we are good to go on to the next step. So I would just minimize this, and we're going to bring up Meshlab with a slightly intimidating icon there. Icon, get it? All right, and we will start to bring things into here. So this is the home screen when you open up Meshlab. What we're going to do is open up a project. So File, Open Project. So just follow with me here. We're going to find, oh, I put it on the desktop. Tutorial. You're going to open up the NVM CVS file, 00, bundle.rd.out. And this is an important file that we'll come back to in a bit. But what you're going to do is double click this. Brings up a second list. And you're actually going to double click the words list. Now, this is going to seem like it's going to freeze your computer, like Meshlab is going to collapse on you. Don't touch the computer, just let it run. For whatever reason, bundle.rd.out and importing the list, it can be very buggy. It takes a lot of time for the render to show up on your screen. So just give it a minute so you can already see it's not responding. It is responding, it's just thinking. In my opinion, the best thing to do is just get up, go make yourself a sandwich, or watch a YouTube video on a different computer and come back. And we will have the point cloud up on our screen. So I just reviewed the previous part of the video that I made, and the computer was working so hard that the video quality suffered, so I apologize for that, but you can still hear what I'm saying. And the picture only blinks out for a couple of seconds. Okay, so once your render is complete, this is what you are left with. To sort of pan and toggle, you're just going to use the left mouse button. I'm just going to look at it. So it's a pretty big point cloud. Really the only part of the point cloud at this juncture that we want is this right here. If we zoom in a bit, you can see the rock. If you ever need to reposition your point cloud within this center here, you're going to hold the point cloud, hold the point cloud and click Control, and it brings it back into the center. So what we need to do now is edit this point cloud because we don't need these erroneous points. The best way to do that is to select what we want to keep. So you go to this Select Vertices tool, and we select the rock, go into Filters, Selection, invert the selection, hit Inverse Faces, Inverse Vertices, and Apply. And now you can see that the selection is currently everything we don't want, which is great. We're going to go up and hit this button here, delete the current set of vertices, and all we are left with is the rock. Now there's still, there's still a lot of work to do with the rock that itself. We need to get rid of all of these erroneous points. Best way to do that is, again, click this button and just start deleting. What you can do to speed things up is select the vertices, select what you don't want. Careful not to get what you do want in there. I want this part of the screen that's under the rock. Hold down the Control button and go off and click Other Sections. This just speeds it up a bit. And then hit delete. So I'm going to go off and clean this up, and when we come back we will have a clean point cloud to work with. I suggest you do the same. Okay, so I've gone off and edited the point cloud. Two things I forgot to mention. If you turn off the light bulb, you might be able to see the mesh a little bit better. And also what you're going to want to do is turn on the Show Layers dialog. This just gives you sort of a history of what you've already done. These are the photos that were used to compile this particular mesh. I'm sorry, point cloud, not mesh. And this is the layer that's currently on. So we're just going to leave this up on this side because you will need to see the dialog box in a few steps. Okay, what maybe I've neglected to mention, or perhaps you've already learned, is that photogrammetry itself is a scaleless method, so it has no scales. The points are arbitrary in space. So it's important to take measurements while you're out in the field of features on whatever it is you're studying, so that you can scale the object in post-processing, which is what we are about to do now. But before we do that, you should be saving your project. So we're going to hit Save Project. Let's see, PCR, Cloud, clean. And save it in a PLY file, that's fine. All of these options are fine. It's also going to prompt you to save it as a Meshlab project file. I suggest just doing the same. PCR, Cloud, clean. Let me just double check something while we're here. No, we've already exported the mesh. We're fine. Okay, so you're going to need to scale this model. So I know the real world distance for some of the features that you see on this rock. So for example, the distance between this point right here, the left ear, and the tip of the tail, I know in reality is 37 centimeters. Excuse me. However, in virtual reality, it's actually 0.810843. So just write that number down somewhere. And so we need to compare the real world value with the virtual world value. And this is called a scaling factor. So it's the ratio between the real measure and the measure you get in the 3D model. So you're going to bring up your calculator here. We know that the real world measure is 37 centimeters. We are going to divide it by the 3D measurement, which is 0.810843. So we get a scaling factor of 45.63 with a lot of decimal points. So we know our scaling factor. We're going to go into filters, normals, curvature, and orientation. Down to transform scale. And you're going to just use this value, the x-axis value, and you're going to type in your scaling factor, 45.63. If you freeze your matrix, you're going to change your model forever. I think that's a good idea, but you do what you feel is necessary. You're going to hit apply, and there we go. Your model is now scaled, and as you can see, the dialog box has updated. To return your point cloud back into the space, you're going to hit Control H. There we go. And it's always good to check your work. So let's zoom in a little bit. Measuring tool from the... Okay, now the measuring tool doesn't want to work. That happens too. There we go. 57. No, where did I go wrong? 35.89. So that's pretty close to 37. You can continue to try to find the points. It's very finicky. It might be off by like 1 point, which gives me a little bit of error. So I think that's a pretty good match. I'm going to X out of that, zoom out a bit, and now we're going to go on to actually creating a mesh of the point cloud. So these next steps take a little bit of time, so just be patient. Before we start creating the mesh, we're going to compute the normals. So you go into filters, normals, curvature, and orientation. compute normals for point set, which is back up here. I keep the default values. You can play around with these numbers. If you're not sure what each of these options mean, you can click the help button. It gives you an idea of what you're actually doing. I keep the neighbor sum at 10. I'm going to apply that. And we can see applied filter to compute normals in 770 milliseconds. So the normals have been computed. Now we're going to go on to the surface reconstruction. So this is actually the meshing. Filters, point set, surface reconstruction, Poisson, if you're French. And I found for this particular model, after playing around for a couple of hours, that the best set of values is 12, 6, 1, and 1. Again, if you're not sure what you should be doing, I would check the help. This help dialog box is actually pretty useful. Going to click apply, and you're just going to let it run because it will be thinking, and it will eventually come up with a mesh. And here that mesh is. So we can see it. It's sort of overtaken the point cloud. We can actually go up here and turn the point cloud off. So just that little eye, click that little eye, and then make sure you hit this one Poisson mesh again so we know which layer we're working on. So here it is. You can see some detail here that's exciting. Let me just see if the lighting changes. Double-sided lighting, so what I did is render lighting, double-sided lighting. It gives you a little bit more, but it actually doesn't do much in this case. But it might for your own project, so that's there for you. We're going to save this again. Save the project. Keep those. Once again. Oh, that's an offensive sound, sorry. We've already done it. Okay, sorry. This new version of Meshlab does 2 steps in one, where my old version just did 1, so I'm still learning it. Sorry, video died there. I was starting to say that we are nearly done with Meshlab, but these next couple of steps are going to allow us to bring the model into Blender and apply a texture to it, or a draping, if you will. They'll go over this entire model. Couple things we need to do first. So you go to filters, cleaning and repairing. Remove faces from non-manifold edges. There we go, at the top here. The filter has been applied, and this just allows us to bring it into Blender with fewer issues down the road. Now we're going to generate a texture. So you go into filters, texture, parameterization and texture from registered rasters. I like to up the ante, if you will, in these areas. So I do 4096. I'm going to change the name of it, so PCR texture. I'm actually going to tutorial texture. I am going to do UV stretching, and I am going to apply. And so the computer is going to be thinking about this and eventually spit out a texture that we can look at. So as you can see, the mesh has the texture has been created. It took quite a bit of time, 874 seconds, which is just under 15 minutes. So, like I mentioned before, this is a bit of a waiting game. So we can X out of this. You can see the mesh has sort of been applied, which, to be quite honest, is the first time that's ever happened to me. I've run this particular simulation 4 times in preparation for the tutorial, so I have no idea what that is. But I'm at least comforted by the fact that the mesh looks just as I remember it. So let's go ahead and assume we do not have a problem here. I'd encourage you to go and check to see that the texture was rendered properly. I can't seem to open up File Explorer without the recording crashing. So what you're going to do is go into your PCR folder. You're going to double click the nvm.cmvs file 00, and somewhere down at the bottom should be your texture, which I've loaded up here. This is sort of what it looks like. Okay, now I just need to save the project again. PCR tutorial final. That saves it. We're going to export the mesh as PCR tutorial final. That's a PLY file we've just done, and then we're going to do one more. Oops, sorry. We are going to save it as an object file. So I want to export mesh as, save it as an OBJ file. This can be opened by Blender. And give that a second. Excellent. So we're done with Meshlab. We can exit out. We can also X out of VisualSFM because Blender does take a lot of computing power. So go ahead and open Blender. Now there are a lot of tutorials on YouTube about how to use Blender, and I encourage you to go check those out, but I'm just sort of going to give you a crash course here. This is the interface that you see when you turn on Blender. If you would like to pan around, you're going to use the keypad. So I'm using the number 6 here. So basically 4, 8, 6, and 2 is going to send you all the way around and back. So anyway, give that a go. I personally like to start without a lot of noise up in here, so we're just going to turn off the cube and the camera and the lamp for now. We will come back to the lamp. So you're going to go to File, Import, Wavefront or OBJ object. You're going to find your destination. I had to go back and create a couple of different options because something had crashed on me, but I figured it out. So let's just go to that file that you saw me create. I'm going to import the OBJ file and give it a second because it does take a while. It's a large file. Okay. We zoom out, we see our model here. To get your model back into the center of this grid, you're going to hit Control Shift Alt C, Geometry to Origin, and there it is filling your screen. Let's just zoom out here for a second. If you hit the R, you're going to rotate it 180 degrees. I'm going to go slow because the capture doesn't quite keep up. You're going to hit R again, and you're going to be able to go left and right. So let's just get it sort of centered that's good enough for now. Okay, so now we're going to set the texture. So let's pull this out just a little bit. And hit this checkerboard, new, image or movie. You can click this button here, PCR tutorial texture. It's already loaded up. It was brought in with this model. If you don't see that, you can always go to open image and search it yourself. This is about what it looks like. We're also going to go into material, and for now click shadeless because the proper shading and lighting is not part of this model as of yet. Going to come down to here, method to display object in 3D view, texture. Now it's totally blacked out, it looks a little scary, but that's why we need the lamp. So we're going to turn the lamp back on. Going to this drop down menu, lamp. You can also get to lamp from this menu bar here. And we're just going to make the lamp the sun. So here we go. This is the model. It's got a bit of shading because we have chosen the lamp as the sun. But this is your model with your texture overlay. Now, as you can see, the texture overlay is not that great. This is fine for the purposes of this tutorial, but when you are creating a texture for your own model, you're going to want to investigate options and ways to get this to look a little bit better. I found that when you scale the model, the texture has a really hard time being draped over. So for example, let's just save as, and I'll show you what a model looks like when you don't scale. So we'll just rename it PCR tutorial final blend. I'm going to save it as a Blender file. Give that a second to run. And I'm going to open a recent Blender file that I made. This is what the file looks like, or sorry, the model looks like when you have not scaled it. So you can see it's a lot smaller. And you can actually sort of see what's going on here. I mean, you can sort of see the orange cat there. If you go up, you see green. Now, green wasn't part of the rock. What I suspect the problem is noise. If you remember when we had the VisualSFM cloud up, we saw a lot of extraneous points everywhere. The camera was picking up the trees in the background, so this is what I suspect that is. But anyway, this gives you an idea of what these programs are capable of, what you can do with them, and I would encourage you all to become experts better than I, and then share your workflow with us so that we're able to learn from your trials and tribulations, if you will. So I hope you found this tutorial useful. Please contact me if you have any questions. My email is up on the geography website, and let me know if there's anything I can help you with. Good luck!